Welcome everybody to the theory of constraints. The objectives of this presentation is I wanted to have a way to get people to learn more about the theory of constraints and how it relates to Agile. Because I think there are a lot of people out there who are using Agile and inherently doing the theory of constraints, but they don't know they're doing the theory of constraints and they don't understand how it can help them. So I hope when you leave this section today, you come away with one more, come on in, you walk away with one more little item in your toolkit that you can draw on from the back of your mind when you get into a situation in planning that you don't know quite how to handle. So I'm going to provide insights in a model that can help improve your planning process, or at least help you get out of a jam when you get into it. Of course, it's just a model. As Doc said this morning, all models are wrong, but they're useful. One thing I learned at the keynote this morning, and discuss, one of many, and discuss some common examples where theory of constraints can help you. I'm going to be talking somewhat fast. I do have a fair amount to get through. If you do have a question or I skip over something quickly, don't hesitate to stick your hand up. But I'm hoping to get through most of these slides in about 45 minutes, and then we can have some questions at the end. So hopefully it'll leave ample time for that. And we're getting started a couple minutes early, so. So please keep in mind some things that I need to point out. I sold this to the presentation proposal system as a basic level presentation. So I don't know what your levels of Agile proficiency are. I'm going to assume that most of you are probably fairly new to Agile, or we're getting into a space that you're not overly familiar with. So I will be dwelling on some basic principles. I hope you don't mind. I may skip over some stuff. If I go over something that I think might be basic and you don't quite understand, again, don't hesitate to ask me to repeat it. I'm methodology agnostic. I sometimes do Scrum, I sometimes do extreme programming. I really don't care. I try to use generic terms. So when I say something like iteration, what I'm actually referring to is a sprint, which is more of a Scrum term. But again, I'm intentionally trying to keep to things like iterations. I may sometimes say sprint, interchangeable. Hopefully it's all clear. Another one is increment versus a story. They're one and the same. Story is just a common name for a piece of functionality. And I'm providing you with guidelines and recommendations. Again, it's a model. It's not always right. Don't take everything I say as gospel. It's just, this is some stuff that I've learned and seen out there in the world, and may apply to your situation. Your situation may be different, and that's cool. Just keep that in mind. So the agenda, what is theory of constraints? Kind of compartmentalize the first two items. Hopefully we won't have to spend a lot of time on the basics of Agile planning, but I think it's important to get a baseline out there for everyone. And then we'll talk about how those two marry together and how they work. And then I've got a couple very simple case studies and hopefully some time for questions afterwards. And I'll announce each one of these subsections as we go through it. So hopefully no surprises. Who is this guy? So my name is Lawrence Ludlow. I've been doing Agile since 2000. When we started doing extreme programming at IntelliWare, there was no such thing as Agile. And I've worked on many different projects in a bunch of different roles, from project management to quality assurance to business analysis. Right now I do mostly coaching work in different companies. And I've also been director of Toronto Agile Community, the people who bring you this lovely event, since day one. And I'm happy once again to see a full crowd here today, and it's just really great. Thanks everybody for coming. People make the event what it is. Enough about me. Let's talk about this guy. So this is Eliyahu M. Goldratt. He first wrote about the theory of constraints way back in 1984. Introduced in his book called The Goal. Highly recommend that as a read. It's kind of a story about somebody in a manufacturing operation trying to maximize their operation. So it's a light read, but it's interesting. This book here, how many people have read The Phoenix Project? If you get a chance to pick this book up, I strongly recommend you read it if you're in IT at all. It's also a light read. It's a quick read. This came out, I think, in 2015, last year. It's full of theory of constraint references. So this stuff that Goldratt proposed 22 years ago is still relevant. So who knows what the definition of the theory of constraints is? Because I understand from somebody I work with that she actually was taught this in school. So some of you may already know what the theory of constraints is. Anybody want to suggest anything? Yes, sir.
The throughput of the system depends on the bottleneck.
I couldn't have said it better myself. That's right. Overall throughput of a system is limited by at least one constraint, and that is equal to the capacity of the constraint. So there's a picture of a chain here. It's not unlike the strength of the chain is equal to the strength of the weakest link. So here's the way I like to describe it. So imagine you have a process. So your process is this pipeline, right? You have something that has to go through multiple steps. This process just happens to deal with little circles. Doesn't matter. Could be anything. Could be automotive parts. Could be software. And you've got a red step. And see, it can handle, there's 7 little circles in there, so it can handle 7 little circles at a time. You have a blue step, 7 circles, it has the same. Uh-oh, the green step, it can only do 3. So that means that the purple step after it can only do 3, and the yellow step after that can only do 3. So the capacity of your system is 3. Any guesses where the bottleneck is here? It's the green step. The green step is controlling the overall throughput of the system, which is 3. So what's happening ahead of the green step? Any guesses?
Lots of queuing.
Yes, you've got inventory piling up ahead of it. And that is waste, right? Anything that these guys produce that this guy can't handle just ends up sitting there, and that ends up being waste because now that's inventory that's getting queued up and sitting there and not doing anything. It has to be stored somewhere. Who has taken a trip down the 401 in the last 15 years? Between Toronto and Windsor. Notice there are a lot of trucks on the road? Those are all trucks going between the car manufacturing plants in Oshawa and Windsor and Detroit because all of the parts for the cars that get manufactured in Oshawa are trucked in on a just-in-time basis, so the automotive plants don't have to store those parts for when they make the cars. They arrive just in time so they don't have to be inventoried. Because inventory, the building, the storage time, is actually waste because it doesn't directly contribute to the end deliverable of the manufacturing of the car. So they minimize that by trucking the parts in just in time. In the same way that if you've got inventory sitting up in front of a step in the process queuing up there, that's waste. Likewise, downstream, you're going to have capacity that's underutilized. That's these little dotted circles here. That's waste too because you've got potentially machinery or resources, people, who are underutilized because they can't make use of the stuff that's being queued up behind the bottleneck. So how do you fix this? Any suggestions? So what you do is you exploit it. You find a way, you focus on the green step, and you find a way to increase its production. And so if you increase the green step's production, what's going to happen? The bottleneck is going to shift. It's going to end up going down to the purple guy here because its capacity was only 5. You've still got inventory queuing up, but of course less. And therefore, you can use more capacity in the yellow step. There's still some waste here because there's underutilization, but overall, you've increased the capacity of the system. And so that is all of, like, there's a big part of the Toyota production system which is based on this. They have Kaizen teams that go around looking for bottlenecks and finding ways to try and improve them to improve overall throughput of the system of making cars. So this is not new. This is, automotive operations have become very good at this over the last 20 or so years. Toyota has done it for years. North American manufacturers, in order to be competitive, have figured out how to catch up. So how does this all relate to Agile? Well, you know what this is, right? This is your traditional waterfall process. I'm not going to talk a lot about this, but I thought this was a good starting point. So traditionally, you build software in a stepwise fashion. Requirements, build, test, deploy. In reality, what Agile does is just basically take that process and chops it up into a bunch of little iterations. And admittedly, within each one of these iterations is actually a mini implementation of this, right? Within each implementation, you need to figure out what the detailed requirements are for your stories that you pick to go into the iteration. You then design, build, test those, quality assure them, and deploy them. So throughout your iterative agile process, you're basically doing a bunch of mini waterfalls. So in a kind of like a stepwise fashion, it looks like this, right? Design, business analysis, design code test, quality assurance, deploy. So you can imagine that then this is like similar, like a throughput process of something going in one end and coming out the other. So the throughput or capacity of each iteration or sprint is basically going to be governed by whichever one of these steps is your bottleneck or your constraint. So according to the ToC, the capacity of each iteration is the bottleneck by the constraint of the steps. And the bottleneck will also control the overall capacity of your system. So what I'm saying here is that what I have found is that often if you've got one particular area, I'm going to pick on design, coding, and testing because usually that's where the constraint ends up being. If that ends up being your bottleneck in one iteration or sprint, it's probably going to be the overall bottleneck for your whole project. That just seems to be the way it works. So of course, to increase the capacity of the system, you need to identify where the bottleneck is. Again, this theory of constraints. And optimize it and potentially move the constraint down the stream somewhere. So that's theory of constraints 101. There's a lot more to it than that, but for the purposes of my message here today, that's probably all you need to know. Next is just Agile Planning 101. I'm just going to quickly skip through this. So of course, Agile is all about iterative incremental, sprints, stories, right? You have a bunch of stories. You have a bunch of planned out iterations or sprints that you're going to work with, right? Usually they're all the same length. If you organize your backlog, your stories, your increments of functionality into a prioritized list, then Agile is all about basically pulling stories off of that list or your backlog in priority order and building them on a sprint by sprint basis. Right? So to do that, you need two key concepts. The first one is you need estimates, right? Because stories come in different sizes, right? You have small stories, medium, large stories. They're not all the same size, and you need some way to figure out how much effort it's going to be to actually build them. That's important because you need to know that not only for how many of those can you put in each iteration, but your customer may need to know how big they are to make priority decisions, something that'll, that's big and has low business value, may be lower priority to them. So, and also based on your team context and your business domain, sometimes teams can do lots of short iterations with lots of small stories. Sometimes you end up with larger iterations with larger stories. Again, it's not one model fits all in terms of what works best. It's largely driven by the context of the size of the project and who you're working with. So I talked about estimates and effort. So what is effort, or what is an estimate? It is a measure of effort. So the thing is, and what drives a lot of this, is that we humans are really good at estimating effort, very bad at figuring out actually how long it takes to do something. So if you have ever read any of Mike Cohn's books, he, particularly in his Agile Planning book, he stresses you estimate effort, that's the amount of work to do something, you calculate or you derive duration. So in a good example, and I've kind of like from my real life, if you were going to do a landscaping project in your backyard and you ordered this nice pallet of bricks here to work with, but you live on a street with houses with narrow driveways, you're going to have to figure out how to get those bricks because the landscaping company is probably going to drop them on your driveway here. You're going to have to figure out how to get them into your backyard. So again, if I've got my load of bricks and I'm going to use a wheelbarrow to wheel the bricks into the backyard, I actually counted the number of layers and how many are on each layer. I think there are about 640 bricks there. I've got nothing better to do. And I'm guesstimating is 20 bricks per load in the wheelbarrow. So the effort then is 640 bricks divided times 20 bricks per load is 32 loads. So that's a measure of effort, right? It's going to take me 32 loads to get those bricks into my backyard. Another way to look at the effort is if I assume it takes 15 minutes per load, times 32 loads, that's 8 hours. So that's another measure of effort. That's not the actual duration because of what's this concept called supporting work. So, right, so that's where we need velocity. Velocity is what you use to convert effort, the amount of work it takes to do something, into actual duration. So my favorite example around this is a baseball game. How long is a baseball game? Anybody know?
3.5 hours.
Yeah, the average is around 3 hours. There is, because it's not a time-dependent thing, baseball is really cool because, like, cricket's the same, right? It doesn't have a set time frame. It has a actually, there's a set amount of work that you have to do for a baseball game. You have 9 innings of work to do. That's your effort. So one measure of effort for a baseball game is 9 innings, or 54 outs. If you made the assumption, well, 15 minutes per inning, that gives you 2.25 hours. Well, wait a minute, but we just said the baseball game was like 3.5 or 3 hours. So what's the difference there? That's because this 15 minutes per inning doesn't include stuff that goes between innings. You've got breaks between innings. You've got the 7th inning stretch. There was an interesting argument on Hockey Night in Canada on Saturday night. If you switch pitchers, the new pitcher gets as long as the pitcher needs to warm up. They can throw as many practice pitches as they want. Whereas in hockey, if they need to switch a goalie, they have a set time frame. And there's a big debate now going on. The NHL managers meetings are coming up. They don't know whether the time that they give the goalies is actually enough time for the goalies to get properly warmed up. If they've been sitting on the bench for 2 periods and they're expected to go out in the middle of the 3rd period and the game's on the line and they don't have proper time to get warmed up. Anyways, if you switch pitchers in a game, it can take that pitcher an invariable amount of time to actually get ready. So that's what I call supporting work. The time breaks between innings, 7th inning stretch, that's the equivalent of supporting work. So going back to my brick example, that 32 loads or 8 hours of effort might not take into consideration, I'm going to need to take a break. I have to go to the bathroom or something. My neighbor's probably going to walk by. There's some guy over on the next block, and if you start doing something interesting in your front yard around your house, he suddenly comes walking by with his dog. It's incredible. So he likes to chat, right? So he'll start talking. You don't want to be rude. You can just tell him what you're up to. But that is supporting work. That's not in your effort estimate. So you need to take that into consideration. So the duration to complete something is actually made up of 2 components. The actual effort, so that's your 32 loads or your 8 hours, and your supporting work. So if you keep that in mind, then this is me after I've done 4 loads. So let's say it actually takes me 10 hours to move those 32 loads of bricks. So that means that basically every hour of moving bricks, I'm going to end up taking something like 15 minutes of breaks. So what does that mean in terms of velocity? Well, one way you can look at the velocity is 8 hours of effort over 10 hours duration is 0.8. So my velocity is 0.8, like 80%. I'm 80% effective on my duration or on my effort, which means my duration will always be more than my effort, which it should be. Okay, or if I take that 8 hours effort and divide by 0.8 velocity, I'm going to get 10 hours, which is my actual duration. Or if I take my 32 loads times 8 hours per day, or 32 loads over 10 hours and 8 hours per day, that means I can actually do 25.6 loads per day, per 8-hour day. That's another form of velocity. So all of these forms of velocity come into play in Agile, depending on how you go about doing your estimating. Which is the segue into the next piece I wanted to talk about. I found that in Agile there are basically 2 main ways of doing estimating and relating estimates to velocity. What I call relative and absolute. I'll start with relative. I think this is probably the more traditional way. So basically stories are sized amongst each other based on relative measures. So t-shirt sizes are a common example, right? You can say that you've got small stories, medium stories, large stories. And if you do your estimating this way, really these are just virtual measures, right? It doesn't matter how big 1 point or 2 points or 3 points is. And as a matter of fact, I've seen examples where particularly long-running projects, they get good at making their stories all the same size. So really, everything's a medium. So that means that the velocity basically is the number of stories per sprint. Or you could say number of points per sprint or iteration. You could say number of tomatoes. It doesn't matter because it's all a relative measure. What's key here is that it doesn't matter how much 1 point or 2 points or a tomato is. What matters is that 1 tomato or 1 point versus 2 points is twice the work of 1 point. Because the way you're measuring your velocity is in points or tomatoes or whatever stories per iteration. So basically the way this works is that your velocity is basically a measure of units. So this is like loads per day or stories or points per iteration. And this effectively converts effort into duration because you know how long your iterations are. Your iterations are often consistently the same length. So what ends up happening is you're building in a time sequence or a time frame around that velocity or that pace so that you know exactly how long it's going to take to do 10 points. So this is, and again, I've seen examples where teams size their stories all the same and there's just the same number of stories every iteration that they choose. They don't have to worry about how big the stories are. But I mean, that's not an easy point to get to. So again, I said this is what I've seen as being the more traditional approach. However, it comes with lots of drawbacks. One of them being is a point or a tomato, that's an abstract measure. People find it hard to relate to exactly what that is. Another challenge is it's difficult to budget. So how much does it cost, right? If you're trying to set out a budget for a project and the team's gone through and sized all the stories, 1, 2, and 3 points, and they tell you it's 100 points, that gives you no idea unless you know what the team's velocity is around how much that's going to cost. And of course, at the beginning of the project, you don't know what the velocity is. So often, the best way to figure out velocity is to probably just start an iteration and do an iteration's worth of stories and see how many points you actually get done, and then use that for the next iteration. A lot of project managers don't like that because they need to generate a budget number before you actually start development. So this doesn't work for them at all. And it's hard for the team because they don't have a lot of confidence that they know exactly what a point is and whether or not something that's 2 points is twice the work of 1 point. The biggest challenge I've found with talking to various teams I've worked with is it gets hard to adjust. People come and go from the team. Things change on the team. If you basically are taking an approach where the number of points or the velocity in terms of number of points or number of tomatoes or number of stories completed in one iteration is based on what you were able to achieve in the next iteration, what happens if the next iteration is not the same? Can you rely on that number? There are a bunch of rules in the original Agile scriptures that say, well, you just have to, they call it yesterday's weather. You have to assume yesterday's weather applies. If you had some team members, you know that those team members aren't going to hit the road running. They need to get trained up, so they're not going to add to your velocity. That's the way it's supposed to work. I found a lot of teams find that hard to relate to. So most teams end up actually doing what I call absolute estimating, in that what they do is they try and stick a time estimate, a time measure onto their estimates. And that comes out in this idea of an ideal day. So an ideal day is basically a level of effort, an amount of effort across a particular time frame, in this case a day. So an ideal day is 1 day of uninterrupted work. I think I get into that here. Right, so it's time to complete something with no distractions and interruptions. It still reflects effort, but it's just given in terms of a time frame. If you know the number of ideal days, then you can make so if I went to my project manager and said, oh, I think this is 100 points of work, they're going to go, well, what does the point mean? If I tell them that it's 100 ideal days, then they, well, okay, a day. So we know that an ideal day is going to be less than a calendar day. So I can just apply some sort of velocity calculation and bump that up, and then I can multiply that by your charge out rate per day if you're a consultant, and I can come up with a cost. So this becomes something much more relatable in terms of budgeting. So in this case, then, because an ideal day is always some function of something less than a real day or a calendar day, then your velocity is always less than 1. So again, right, if it took me 10 hours to do 8 hours of effort to move my load of bricks, then that's 0.8 as I used before. In this case, your velocity is some number less than 1. Here's the big question. When I say it's going to be an ideal day to do this story, what effort am I talking about? Whose ideal day am I talking about? This is where I find teams get caught up a lot. Right? What does an ideal day mean? Is it an analysis effort? Probably not, because most people accept the fact that before you do your iteration planning meeting, you already have to have a lot of your business analysis done, right? They don't put that in the estimate. It's usually done before iteration planning because you need to know, usually the business analysts need to run slightly ahead of the team and have a lot of the details of the stories figured out before they do planning. Could be development, design, code, test, quality assurance. Could be easily either of those. Sometimes it's all of the above. But the thing is that you need to be clear on when you do an ideal day estimate exactly whose time you're estimating. And this is where the theory of constraints, I think, can help you. So now I'm going to take this stuff. By the way, I should add, any questions about this? I mean, this is kind of, I've gone through this fairly quickly. Is this all fairly straightforward for you? Any glaring questions? Confused anybody in any way? Cool. All right. So now we get into the really interesting stuff. How does this relate to Agile? So I've talked about the basics of theory of constraints. I've talked about the basics of Agile. Now I'm going to munge them together into this. So remember this diagram before, right? Applying the theory of constraints to your ideal day estimate says that you need to assume that one of the steps in these processes is your bottleneck, and that's where your estimate should lie. So you should do your planning around your bottleneck and assume that the other steps in the process are running in slack. That's the basic premise of how the theory of constraints applies to ideal day estimates. If you're doing absolute estimate or relative estimates, you're really just planning throughput of the number of stories you can finish in an iteration. So this stuff really doesn't apply there. But when you start doing absolute estimates with time frames against them, you need to be sensitive. Okay, exactly whose time are we estimating? And the best way to do that is to apply the theory of constraints, assume one of these steps is your bottleneck, and then assume the other steps are in slack. And I'm going to go over some examples of that in particular. So in a lot of cases, it tends to be design code testing, but it doesn't always have to be. So when you do planning this way, it becomes really a simple exercise of you've got your ideal day estimates for your stories. You know how many team members you have. You're focused on one particular bottleneck. You know how many people are going to be working on that particular constraint, be it QA or design code test, development. You have your story priorities. So then really your planning meeting is just really figuring out how big is the bucket, what's your capacity, how many ideal days of time do you have available within your constraint, and you know what the priorities of your stories are. You know how big the stories are in your ideal day estimates, so you just basically throw stories by priority into the bucket until the bucket fills up. And I've got a really good example of that coming up. Big question is, before I get into the example, is what do you use as a velocity? I have found an almost universal measure that teams like to use is 2/3. So that means that 2/3 of the time you're actually doing effort, real work. Well, everything's real work, right? But only 2/3 of your real work can actually be against your ideal day estimates of effort for your stories, right? So my velocity on moving my load of bricks was 80%. This is 67%. Sometimes you need to tweak those estimates a bit. So yeah, what I'm saying here is basically 2/3 versus 1/3 of supporting work. And a lot of this supporting work on a development team is going to be planning meetings, ad hoc design discussions, stand-up meetings, stuff that is project related, but not necessarily direct production of stories. That supporting work is really important and it's essential. You have to build that in. You need to be careful with how big of a number you use for your velocity. 67% might not sound particularly high, but the fact is that other supporting work is critical. And sometimes you can tweak the numbers a little bit. So some leadership roles like team leads, senior architect types, people who've been, senior developers who've been with companies for a long time, they may have legacy projects they need to worry about on the side. So their velocity may not be as high. Sometimes a lower number, like 50%, works for them. Sometimes you've got junior intermediate roles who don't have the distraction the other guys have, and you may be able to go slightly higher. But I don't usually recommend going too far off the 2/3 number for a team average. Okay, so how does it work in real life? So what I like to do in my iteration planning or sprint planning meetings is identify what your bottleneck is going to be, what you're going to do your planning around, quality assurance or development. List the team members one by one on a whiteboard's really handy for this. Just put a simple table up with a whiteboard. Figure out how many work days are available. So by work days, I mean if you're doing a 2-week iteration, you've got 10 business days. Now, if there's a holiday in there, then that's 9. Right? So any day that the team is not running, you need to automatically take that off. Don't count that in, right? This is often the way I find teams get burned, is they don't take into consideration that they've got a stat holiday coming up in their 2-week sprint. They go out and plan 10 days, and then they realize partway into oh crap, we can't get everything done. We don't have a day to work with. And that's important, right? That's 10% of your productivity there if you don't take that into account. So put down the number of work days. This is another key part, non-project days. Again, you're going to get people who might have a vacation day planned during the sprint. They might have to take half a day off for a medical appointment. They may have to go work on another project for a day or two. You need to take that into consideration because that's time that they're not able to work on the effort to do the stories within your project. They may be working on other things, but that other stuff, you can't put that into your plan. You have to weed it out, and this is a good way to do it. So just simple math then is you get a net number of project days, which is just the work days minus the non-project days. With that number, then you can apply your velocity. Remember, your velocity converts your effort, which is your estimates, to your duration, right? This is all within your project, right? This non-project days is stuff outside your project. This takes into consideration time within your project, but helps to account for, again, stand-up meetings, design discussions, ad hoc whiteboard discussions, stuff that you can't plan for. So then if you do the multiplication of the net project days by the velocity, you get an equivalent of an ideal days estimate of the time available. So in this case, then you just add up the ideal days. In this case, it adds up to 20. There's your bucket. That is how big you have, or how big your bucket is for your iteration planning meeting. That means that if you've got your stories estimated in ideal days, then you can pick stories until you get to 20. You could be a little less, maybe 1 or 2 over, but basically you're aiming to go to 20. And then so now you can talk to your product owner around, okay, we've got 20 ideal days to work with, we've got stories estimated, which stories are we going to put into the sprint or the iteration? And then based on their priorities, you can then fill the bucket up with your 20 ideal days of available capacity. And then they might tweak the priorities a little bit because often product owners, customers like to maximize things or fit things together and come up with an ideal, well, something that can demonstrate at the end of the iteration. So this always begs the question, well, what about the roles that aren't in the constraint? So based on the theory of constraints, any role that is not the constraint then should be working in slack, right? They should be not the bottleneck. They should be able to keep up at the pace that the bottleneck is operating with and have extra time to do other things. In reality, they'll be busy throughout the sprint doing all kinds of stuff, but because they're not the constraint, they should be able to run a little bit ahead. That's particularly important for business analysts part of the work process because business analysts often not only need to be running ahead of the team, gathering requirements for stories that are top priority, which are coming up in future sprints, but they're also running behind the team, finalizing documentation that's been completed for stories that are finished up, has built stuff or specifications for things that might have changed during the implementation. So they need to be looking both ahead and behind, and so they need to have some slack anyways. How do you manage this in terms of your iteration planning meeting? What we recommend is that, let's say design code testing is your bottleneck or your constraint. That means that you should make sure that your QA members and your business analysis members are also in the meeting. So if you use the example of design code testing being your bottleneck, you need to make sure that if you pick those 4 stories over there to go into the iteration, that business analysis and quality assurance have the capacity in the sprint. You don't need to plan it, but they need to do a gut check to make sure that they can get those stories done. So, so in this example, this story, it's caught up in quality assurance because there was a big testing dependency, for example, that QA knew was coming up, and so they probably should have said in the planning meeting, hey, wait a minute, we're not ready to test that story. This thing, we've got this other dependency, or we've got this other blocker that we need to deal with. In which case, then you should have a conversation. Okay, well, if we don't do this story, could we substitute it for another story and put this story into a later iteration and worry about it later when you figure out how to deal with the bottleneck. Likewise, with business analysis, often encourage BAs, like, don't let a story go into an iteration unless you're sure it's ready, right? Because if you rush something through, I ran into this last week actually working with a team, turned out that really poor quality stories were getting pulled in iteration because the business analysts were feeling pressured by the product owner to get them get the detailed requirements gathered for them and get them into the iterations before they were ready. That was causing the team a lot of grief because then when QA got to testing those stories, they were reading one thing in the requirements and seeing something else in the implementation, and that was creating a bunch of bugs. And then it was taking a long time to get QA done, and that just bottlenecked the whole process. So I've got an example of that coming up. What about planning around multiple roles? Oh, the simple solution is, why don't we just plan both QA and development? I've seen teams try this. I say don't do it. It's like trying to hit 2 targets at one time. So for example, let's say you have development and QA, and they both feel like they're constrained, so you're going to try and do plans for both of them. That would mean that you'd need to do multiple effort estimates, ideal day estimates, and capacity plans, those tables for each of those roles. And are you really going to do that in front of your product owner? And any red-blooded product owner is going to ask if one of those 2 is underutilized during the sprint, is going to ask, well, can't we do more stories? Right? Yeah, we planned out development's full, but QA has lots of time. Maybe we can fit some more stories in. Don't even go there. I worked with a team last year that ran into this problem. Their QA was getting bottlenecked, and so they tried to do planning around both development and QA, and then they couldn't figure out why their sprint plans weren't working.
Or worse yet, put QA on a different team while they're waiting.
Yeah. That's even worse. I haven't heard that one, but. So a few simple case studies. These are somewhat generic, but they're based on some things that I've observed. This is the most common one. You've got a downstream role from your bottleneck that can't keep up. So that downstream step then feels like they're the constraint, even though it doesn't make sense that they be the constraint. They end up being the constraint all the time. So what you'll see happening is that you'll get stories piling up ahead of them. And team members feel like this is the case I just mentioned. Yeah, you planned around development, but we don't have a plan for QA, and we're really tight for time, and we need a plan too. So then I think you really need to, well, what's going on here? This doesn't make sense now, in that it's obvious that in this case, design code testing should be your constraint, but it ends up being QA. That doesn't make sense. So there are a number of ways you can look at this. One thing you could do is, if you've got a step that's constraining, maybe you could exploit it some way. Maybe in the case of quality assurance, maybe you could have them write more automated test cases or something like that. And, or perhaps another way is there a way that you could move some of the work upstream? So often what I found is that if QA is bottlenecking the process, it's often because there's not enough testing going on up in the development step. And the result is that QA ends up doing a lot of extra testing. This isn't quality assurance anymore. It turns into quality verification because they're basically having to repeat all of the development that was done during development in automated test scripts to test, basically verify all of the functionality, as opposed to really just focusing quality assurance, which is more around behavioral and boundary case testing. Another way you could do this is just reduce the capacity of the upstream step. So you could reduce the capacity, like for example, assume a lower velocity for development so that everything can get through QA. Of course, that will result in your overall capacity of your system slowing down, but at least you won't have QA getting all stressed out and doing a crappy job because they're feeling under pressure all the time. So that may be a way of improving performance, but you're going to lose some of your capacity. Add more staff to the bottleneck step. I don't recommend this. I mean, sometimes it's a solution, but who's read The Mythical Man Month here? As Fred Brooks says, adding members to the team doesn't always make the team go faster. The one I like to use all the time is 9 women can't make a baby in 1 month. Or just simply consider moving the constraint downstream, right? So if you truly are in an environment where you've made the assumption, it would seem logical that development is your bottleneck, but it consistently turns out that it isn't, maybe you need to look at what really the value of your system is. And where the real work is involved. Maybe you have assumed the wrong constraint. Maybe you need to move it to quality assurance. I worked with a team last year where design code test was actually configuration of an out-of-the-box system, but there were multiple stakeholders with very complicated requirements. So we actually started by doing our planning around business analysis and assuming that was a constraint. So then stories moved into the process and through based on the capacity of the business analysis part, because the BAs had to go out and talk to a whole bunch of different stakeholders to figure out what exactly their requirements were. What was interesting about this is in the end, they ended up moving it back to development because they found that they made the assumption at the beginning that this was all just configuration work, but what the stakeholders were asking for required a bunch of customization and custom coding on the out-of-the-box solution. So their constraint ended up moving to development. This next example is the opposite of the previous one. So the constraint step is not running at capacity, and so something upstream is blocking it. So this one is kind of insidious. It's not always obvious. Often it ends up happening in business analysis. And what happens is that it's insidious because you can't see, right? Stories go in. You sign up for stories for each iteration or sprint. But what happens is they don't come out fast enough to the developers, or what comes out to the developers isn't good enough quality. So this is the example I used before. This ends up burning you because when the developers, they go ahead and make assumptions because the requirements aren't clear enough. They code something and then it goes to quality assurance and they start looking at it and like, wait a minute, this doesn't do what I thought it was supposed to do. And then you end up with multiple cycles of issues being identified and circling back and a whole bunch of side discussions around, well, exactly what was this intended to do, or how is this supposed to work? Oh, wait a minute, we didn't add that detail. We didn't have time. Whoops. And that will end up taking you a lot longer in the long run than it would have been to do it right in the first place. So the solutions are similar to before, slightly different. Of course, you could improve the capability of the bottleneck, find some way of exploiting it. For example, if your business analysts are getting bottlenecked because somebody they need to talk to who understands the requirements on the business side isn't available, maybe you need to escalate that and get the product owner to talk to somebody on his side or her side to free up somebody's time who knows the requirements. So or you could just manage the work intake. A good example of this is, you're in an iteration planning meeting and the product owner says, this story is a priority, but business analysts haven't had time or are getting bottlenecked by somebody's availability to figure out exactly what that story needs to do. Make sure the business analysts are speaking up. Hey, we can't do that story. We're not ready for it, right? So you're essentially managing the work intake of the process by deferring a story till later because it's not ready to be developed now or you don't have the requirements for it. Of course, you can move work downstream. If you've got some spare developer cycles, get them to help with some of the analysis work. I know sometimes developers don't like doing that, but it's not about who does what. It's more about getting stories through the process. Add more staff. Again, I'm not a big fan of that. Or just simply move the constraint. If you truly believe the constraint is around analysis in his example, it is possible to move the constraint up the cycle. And then that's essentially, in a way, managing work intake, but just you're taking a different approach. No specific issues, except the team's having a lot of challenges with understanding the relationship between velocity and estimates and capacity. But really no specific issue that you can identify. One approach you could take, which is a bit radical, but I can't leave this out, is try going relative. So instead of trying to estimate stories in terms of ideal days, take a leap of faith, just do relative estimates across the stories, or just change your existing ideal days to relative estimates, measure an iteration, and see how many of those you get done, and then use that as your capacity for the next, or your velocity for the next iteration. It's a bit radical. It is a bit of a one-size-fits-all solution. It probably does away with a bunch of problems. Basically, what you're doing is driving the team towards a focus on completing stories, not necessarily, because one of the challenges with absolute or time-dependent estimating is that if you do work across your estimates across one stream, QA or development, then it's very much you're throwing stories from QA to development to, or from analysis to QA to from analysis to development to QA. So those streams end up inherently being somewhat independent, like considered independent of each other, or really they shouldn't be. If you do absolute estimating or relative estimating, if you do absolute estimating, you do kind of create silos to some degree. If you do relative estimating, what you're really doing is saying our measure of velocity or speed or the pace that we're getting things done is not around the ability to push stories through development or through QA. It's really the ability to get stories done from front to back and deployed, or at least ready to be deployed by the end of an iteration. Of course, this means that you have to have stories go in and be ready at the end of QA within a reasonable time frame at the end of the sprint. There's a bunch of rules you can apply around, well, maybe you could let one slip a couple days, but essentially what you're saying is at the end of your 2-week iteration, stories are done when they're through QA, and that's not always easy to do. So that's it. What are we doing for time? We got about 15 minutes, so right on schedule. So that's it. Questions? I think gentleman, black shirt back there, you were first. Can you stand up, please, just so, because we're recording this, so make sure we hear.
About the other rules that you mentioned, that the other rules that do not have constraints, right?
Right.
So we can use that slack time. For example, if a VA does not have a constraint, but eventually during the development is the bottleneck, how would VA help for the development if a VA has a slack time, and how do we estimate? Remember, we estimate 2/3 and 1/3.
Right.
How do we estimate the people who do not are a part of a bottleneck?
Because you don't estimate them, right? That's essentially what you're doing. Is if development is your constraint or your bottleneck, all your estimates should be around that constraint. So you actually don't estimate the other roles. You assume that based on the theory of constraints that they have some slack in their schedules, that they can keep up to what you do your planning around, and that you don't have to estimate their effort. So
Can we say they will be operating at 100%?
So, yes. I think the short answer to that is yes. That well, again, they're going to have, so yes, they're going to be working at 100% of their capacity to work on the project. It actually doesn't matter how much supporting work they do and how much effort, or in this case, story work they specifically do. Really doesn't matter. What you need to assume is that they can keep up to whatever your planning constraint is. And then if they can't keep up, then you need to look at what's potentially bottlenecking them or move the constraint. But don't estimate something that's not a constraint. Otherwise, you get into the scenario of trying to estimate and plan against multiple roles within the team, and that just gets complicated in a hurry and confuses things. Does that help?
Yeah.
Okay, great. Question here?
So you mentioned about different roles such as business analyst, development, QA, product owner, but which role is actually managing this estimation process in Agile?
So the generic answer is the team. I mean, estimating should be something the team does collaboratively. In reality, what I found happens is that a lot of that stuff is actually driven by the business analyst, because the business analyst is somewhat responsible. At least they're the role that kind of runs ahead of the rest of the team, right? They're watching the backlog. They're making sure that they're talking regularly with the product owner to check in. Like, they should be doing what we call backlog grooming, which is sitting down with the product owner outside of sprint planning or iteration planning to understand where the backlog may need to be updated. Are there stories that need to be removed? Are there stories that need to be added? Is there a story that needs to change for some reason, right? In a modern business context, product owner is probably going to be changing their mind on things on a regular basis, not only because, for two main reasons. First of all, of course, business changes as you go. That's why you do Agile, right? Because you need to be able to adapt to change. And the second thing is that there's always an element of, as you build the product or the system, the product owner's view and opinion will change because they're learning also, right? They're learning how the system is actually going to work as it's built. That's why you do regular demos with them. So that's going to change their point of view on what the stories need to do and what the priorities are. Your business analyst should be meeting regularly with them to update the backlog to reflect that. And then that's going to spin off a need to probably estimate new stories, re-estimate change stories. So what we recommend always is that as an outcome of a backlog grooming meeting, the BA should then go back to the team and have a quick 1 hour, half an hour hopefully, estimating meeting to update any estimates that need to change in the backlog because the product owners changed something. And then that becomes supporting work, right? That's something you can't plan for because you really don't know from one iteration to the next how many stories are going to change as a result of backlog grooming. It could be none. There could be a whole bunch of stories that product owners change, which you then need to spend some time with the team doing estimating. But I found that the business analysts, because they need to run slightly ahead and make sure that there's stories prioritized and ready for iteration planning, that often they end up kind of taking a bit of a lead that way. So they go to the team and prod them and say, hey, you know what, I met with the product owner yesterday. We've got sprint planning coming up tomorrow. Product owners change these stories. We need to relook at the estimates for them. So we'll have them ready for the planning meeting. Does that answer your question? Okay. How are we doing for time?
5 minutes after 2.
And we've got to quarter after, right?
I believe so, yeah.
Yeah, okay. So we've got a few more minutes. This guy and then the gentleman in the back. So you first, please.
Sorry. So how do you take into consideration different various levels of experience for a developer? Would you take that in consideration, their velocity? Because you could have like a motorized, wheelbarrow for one person that can get things done a lot faster, versus another one that's just a standard wheelbarrow.
Yeah, that to me should be a team decision. It doesn't always have to be the same. It kind of trades off. Often more experienced developers who might have higher velocities often also have other responsibilities. So I've often found that to be the case. That's why I mentioned earlier, make sure that you don't go too far off that 2/3 number. You might have some More junior developers, and actually it works opposite. More junior developers often have fewer distractions, so they can immerse themselves in the code base more. And I've generally been involved in discussions where we've assumed slightly higher velocities for people who are newer, or they may be experienced, but they just don't have distractions for whatever reason. They could be a highly experienced developer, but they're new to the company, and this is the only project they're working on. You could probably get away with a slightly higher velocity for them, but you need to be really careful. When you start getting into 80% velocities, right, that means 42 or something hour, 32 out of 40 hours a week is strictly writing stories, and there's lots of other things. I just mentioned estimating meetings, stand-ups, right? You are really kind of making things tight there. So, gentleman with the gray shirt in the back, can you make sure you can be heard, because we're recording here?
Oh, for sure. Well, Lawrence, thanks a lot for a very, very interesting talk. I really appreciate that. The question I had was, usually we go around using the POCO model of estimation, which is pretty relative, and we do that along. So this, actually this practical concept is trying to talk about the constraint and apply this absolute theory of estimating to that constraint, right? Or did I get?
Yeah, so you mentioned poker, right?
Yeah.
Yeah, so you've got planning poker cards. The numbers on those cards are essentially ideal of the day estimates. My message here is just make sure you understand whose time you're estimating when you do those numbers. I think this is one of the things that I found is that teams that are new to Agile, they do those estimates, but they don't always understand exactly what those numbers mean and how they apply to their planning process, right?
Yeah, and actually my thought was, the question was around, if you do that for the constraint part, then it actually shuffles all the other estimates which you almost had to the rest of the sprint, right?
What do you mean by shuffles?
Well, you're looking at the constraint, you figured out, let's say, in that particular sprint, like design is actually your bottleneck. So you use this concept and try to figure out
Right.
where and try to exploit it and
Right,
all those
right.
recommended steps for that. And you try to estimate that portion of work. Now everything else is actually also going to change on account of that estimate. It's not really going to be the earlier estimate you did in the sprint or your story, whatever.
Right, but I guess you just have to keep in mind that those other roles, you have to assume are working in Slack, right? So basically, according to the theory of constraints, if you assume that one step in the process is your constraint, then it's constraining the flow of stories through the pipeline. Then the other roles, they're probably working with enough extra capacity they can keep up without necessarily falling behind. Essentially, what I'm saying is they can keep up without having to work overly hard to keep up to the constraint. And if you find they're falling behind, then you need to look at, well, are we playing against the wrong constraint, or is there something bottlenecking them? In a lot of cases, if your gut feel is that there's one step in the process should be the constraint and somebody else is not, and somebody else is slowing the process down, my guess is there's probably a bottleneck there somewhere, or somebody's cutting corners on something. So, and that's kind of like one of my key messages of this presentation is that once you make an assumption of what your constraint is, if there's something that isn't working quite right based on your gut feel of what the constraint should be, then there's probably, you should go investigate and start asking questions, because there's probably a bottleneck there somewhere. So, question here, yes, sir.
If we're basing our estimation on the assumption that there is one role that's acting as the constraint, if it proves that that assumption is incorrect, does that mean presumably it means we have to go back and revisit all our estimates against whatever the new constraint actually is?
Yes, and that's actually pretty rare. You're right, you would have to do that. I haven't actually had to do that before. As I just mentioned, in a lot of cases, if you find something feels like the constraint when you don't think it should be, right? So there's kind of like what you feel it should be the way it works, and if it's not working that way, then there's probably something bottlenecking that other step. So in a lot of cases, you can end up solving the problem by trying to optimize where the constraint's happening where it shouldn't be, and trying to optimize that as opposed to moving the constraint. That's why I put moving the constraint at the bottom, because I think it's exceedingly rare. Your business context will often tell you where the constraint needs to be. So again, I admit I came once close to moving a constraint, and it turns out we didn't have to. So somebody else's gut feel was more right than mine. Yes, sir.
Often stories are selected based on the customer priorities, and always business analysts would say, okay, my story is ready, and then we put up in the sprint, and when we are planning, everything looks okay, or sometimes we know that the requirements are not properly collected or documented. Should that be thrown out or put it back into the backlog until the requirements collected, or you actually continue to the process?
So basically, if something's not, so crap in equals crap out. Sorry, a bit blunt, but the reality is if a story's not ready, the mark of a good BA is that they'll just say this story, they'll know, right? And they'll stick their hand up and say, we can't develop this, because they'll inherently understand if they put a poor quality story into development, then it's going to cause, they might save themselves a few hours time going and bugging somebody for some extra requirements, but it'll cost the team days of effort, because you develop something poorly, it goes into QA, QA identifies a bunch of issues with it, then they start identifying issues, and then when QA identifies things, they log those things, then there has to go back and be a fix. There's probably a follow-up discussion on exactly what's the implementation here, what's the requirement. Somebody may have to go back to the business and ask some questions, and then there needs to be retest, and so a few hours can easily turn into a few days when you start cutting corners that way. Your BA, yeah, as I said, to me the hallmark of a good BA is they're not afraid to stick their hand up and say, hey, this is not ready.
So in supporting to that, the second question is that assume that everything is okay, and it goes into story, and now there is a scope creep, because now customer says some A, and then now BA says, okay, I would like to do this plus this, and the scope creep happens. So what do you do in that situation? Because now you planned the story for 3 points, and now it became 6 or 7 points.
Yeah, so I ran into this last week. The product owner told the BA that this formula should work. They implemented the formula, and it didn't work, and then they basically spent several days of extra effort clarifying exactly what the correct formula was supposed to be, and then fixing it and getting it working. From my perspective, they did that wrong. What they should have done is, because the BA was given a direct indication of what should have worked from the product owner, and it didn't work, then that to me is like scope change. It should have gone into a new story. Okay, that formula didn't work. We created a new story with a new estimate for the new formula that goes in. The new story, of course, will be net smaller, but you're recognizing that a requirement has changed, right? As opposed to what that team did, which was they tried to fix something that was clearly went into the requirements wrong in the first place. So there's only there's stuff that your business analyst and your analysis step, there's stuff that they can control, and there's stuff they can't control. They need to make sure that they're working and dealing with the stuff that they control as well as possible. And if there's something there that they know that they can control that's not right, they need to stick their hand up and say, this story's not ready. If they're given a direct indication from a product owner, this is the way it's supposed to work, and then the product owner realizes after it's built that it didn't work that way, that's a requirements change. You need to put that in as a new story and recognize that there's increased work here, and you may need to bump something lower priority off the backlog because something's changed. But you need to have that discussion. Okay, you told us to do this, we did this, it doesn't work, we're going to need to do that, so we're going to add a new story for that, but something's got to change in the scope. Something lower priority is going to come off, or we can leave it like this because you don't want to take something off the backlog. Right? You need to be able to move the scope lever. I'm getting indication we need to wrap up. So I'm here all day today. I'm here at the reception afterwards. If you have any specific questions, don't hesitate to approach me. And
To vote? App to vote? Vote on your session?
Oh, right. So, right, the conference application, there's a feedback form. Don't hesitate to fill that in. Or there's cards here. Wayne can get those from you. So, thanks, everyone. Thank you for coming out.